This is Unit 5, Lesson 6, Graphing Inequalities. It's important that you know the inequality symbols and be able to read them as though you're reading from left to right. This is the less than symbol, less than or equal to, greater than or equal to. You need to know those and have them memorized. When we read an inequality, we read it from left to right, just like we would a sentence in the English language. Here's an inequality with a variable in it, so we would say x is any number that is less than 6. X is any number less than 6. Well, what numbers are we talking about? What are some numbers less than 6? There's 5, 4, 3, 2, 1. Those are all less than 6, but so is 0. Those aren't the only numbers less than 6, however. -1, -5, and -200, those are all less than 6. And it doesn't have to be whole numbers. 3.5 is less than 6. 5.8, 4.2, those are all numbers less than 6. So there's actually an infinite number of numbers that are less than 6. Now this inequality is a little bit harder to read, but we can think about it as 8 is greater than or equal to any of the numbers that x stands for. X is greater than or equal to any of those numbers x stands for. However, sometimes it's harder to process that. If we think about it, x is greater than any of these numbers, so any of those numbers could be things like 7 or 6 or 5. But if we would like to write it with the x on the left, we can mirror image that inequality and rewrite it so that the x comes first, and then it's easier to sort of understand what the x values could be. So if I write it the other way around, we see that if I write the x on the left, you can see that the inequality symbol has to be the mirror image of the one above since the sides have swapped. You can see that the pointy part of the inequality symbol is pointing toward the x in the first one, and it's pointing toward the x in the second one, so we know that it is meaning the same thing. So reading it this way, we would say x is any number less than or equal to 8. And so the same numbers we're thinking about, 7, 6, 5, and also 8 could be one of those because it could also be equal to 8. All right, so if we're going to graph inequalities, we need to think about what are all the possibilities. So x is less than or equal to 4. That means it's anything less than 4, 3, 2, 1, right? But it could also be equal to 4. So here's a 4. X could be equal to 4, and we're going to plot that. It's a nice big point. But then what are some of those other values? Well, it could be 3 or 2 or 1 or 0. But it could also be some of those other values like -4 or 1/2 or 7/8, 1 7/8. So when we show all of those values, there's so many of them, we could keep writing even more of them. There's so many of them that they basically smush together to form a line. So graphing all the numbers less than or equal to 4 are all of those values from 4 and anything to the left of it on the number line. So we show that by writing an arrow at the end of that line formed by all those possibilities that are smushing together. We're also including the value of 4 because x is anything less than 4, but also it could be equal to 4, so we're including the 4. Now here's another one. X is greater than 1. So we're thinking about the number, and the first thing I do is think about whether it could be that number 1 or not. It says x could be greater than 1, but it can't be 1. So we can't include 1 as a possibility. So we show that by putting what's called an open circle at the 1. The last time we put a solid circle, sometimes that's called a closed circle, to indicate that the 4 was an okay answer. But here 1 isn't an okay answer, but we know that it's going to be everything greater than that. So we're going to show all of the values to the right of that are greater than 1, but we're not including 1 in our answer. Now we don't start it at 2 and just continue from 2 because it could be 1.5 or 1 1/3, so we have to include everything that's right up to 1, but not including 1. All right, example 3, x is less than -3. So we start with our boundary point, -3. Could it be -3? No. So we're going to put an open circle at -3. We're not including that. X is less than that, so it's everything to the left of it. So we write our remaining values to the left of it. Don't forget to put an arrow at the end because it's not just stopping at -6, it's including -7, -8, etc. Example 4, x is greater than or equal to -2. So now we're saying the boundary point is -2, and x could be greater than that, or it could be equal to it. So we do have to include -2, so we're going to put what we call a closed circle. We're going to fill that in to include the point -2, and then it's everything greater than that, so anything greater than that is to the right on the number line. All right, now this next one is a little bit tricky. -4 is greater than x. For me, it's really hard to process what those values should be. I like to have my x coming first as I read it left to right, so I'm going to rewrite that as a mirror image of itself, and then I can see more easily x is all the numbers less than -4. So that means my boundary point is going to be -4, and it's going to be an open circle, and it's everything less than that going to the left. All right, you give it a try. Go ahead and graph this one on the number line, see how you do. All right, x is greater than -1 is an open circle at -1, and our line is going off to the right. You try number 7. All right. X is less than or equal to 0 means a closed circle at 0, and our solutions are showing as a line going to the left. All right, you try number 6. The first thing I do is rewrite it mirror image, so I find it easier that way. X is less than 6, so we're going to have an open circle at 6 and everything to the left of that. Try example 9. All right, x is less than or equal to 3, so we have a closed circle at 3 and everything going to the left of that. That's it. Put your note sheet in your binder and I'll see you tomorrow.